Again, welcome to part 2 of the series, and so in this part we're going to go over how to give the texture real depth with DirectX 11 tessellation, and how to give it sort of fake depth with bump offset, and just how to make a material constant. Alright, so let's open up the material that we worked with. Same one we had before. And now, it looks like there's depth with normal maps, but that's just shading, and it's not really fooling anybody. So what we can go do now is bring it over here, and we add in some bump offset nodes. If the package will back up. Alright, so add in some bump offset nodes. We're going to want one for each texture sample. And so for those of you that don't know, bump offset, it's basically how you use, the easiest way to use parallax in Unreal. Connect this to the coordinate, and what it does is essentially it offsets the texture to the camera position so that you can see. It gives it the illusion of depth. So like where the object would be higher, it makes it look like there's more object there. There's a lot more depth there than there actually is, and it gives it sort of a fake displacement. All right, so bring this over. Once again, alpha to height. And then connect the UVs up. Same for all these. If I'm using Control W to duplicate, it's the easiest way. And the quickest. Alright. So once everything's wired up, you'll see sort of a difference. And it won't look quite there yet because it's only connected to the normal. So right now you can sort of see there's something there, but it's only connected to the normal, so only the normal map's the one that's being offsetted. So you can see there's a bit of just swimming and it doesn't quite look good. Makes you feel a bit seasick sometimes. What you're going to want to do there is connect this and bring this up to the diffuse map so that everything looks correct. I'm just going to bring a texture over, text chord, for when I parameterize this later. Alright, so we got all of our textures, and now they're bump offsetted. And so what you can do is you can see this sort of black line there, and it gives it a bit more of a pop. But since right now these are set to be way stronger than they should be, so you're not getting a good offset. It doesn't look clean. So I found for this material something around 0.2 or 0.3. It gives it a much better illusion of depth without looking too bad. So here we go. So you can sort of see it as I move. The textures are kind of offset, and it gives it a lot more of a depth illusion. Like if I view it in the sphere, it looks a lot more 3D. And so if I pop it into the real world, as you move around, you can sort of see these edges, and that's not the best way to do it. It doesn't look as good as it could, but that gives it a nice illusion of depth, so you can sort of see some depth in there. Alright, and so then after that, you've got your bump offsets, you got your normals, and you got your diffuse. If we're going to do DX11, we got to switch something down here. So obviously, if you got your DX11 card, there's a DX11 tab, and so you're going to want to switch this to flat tessellation or PN triangles. Either works. PN triangles is a bit more expensive. Obviously, it looks better, but it's a bit more expensive, so I usually just stick with flat tessellation, and it works fine. So that opens up these two tabs, which is world displacement and tessellation multiplier. You look those up on the UDN documentation if you want to learn more about them. Tessellation multiplier takes a 2 vector, and displacement it takes I use a linear interpolation for it. So take math, linear interpolate. Linear interpolate's a node that's basically it's a mixing node. It'll take two processes, 2 nodes, or 2 things, 2 diffuses, 2 normals, whatever, and it'll mix them together based on a mask. So you got A, which is basically when the mask is darker, and B when the mask is lighter. So you often, and the alpha is the mask. So you often just take an alpha channel, which in this case will be a diffuse. Not a diffuse, it'll be our height map. Come on, there you go. And so it'll blend based on that. You don't want to use the ones that have been bump offsetted, because when you bump offset something and then you try to displace the mesh based off it, it gives you weird results, and that's not what we're looking for here. So now you need a constant 3 vector because this is a world displacement, so you got to have your up, right, and down. You're going to want to make it blue. So red and green, they will displace in your flat directions, and blue takes it up and down. So you got like forward and back, left and right, up and down. So I'm just going to set this to 1 because I'm going to parameterize it later. So I'm just going to set it to something. And then I'm going to find 1 minus math. 1 minus just takes the inverse of whatever you're putting into it. So if it's a diffuse, it'll give me the inverse colors of a diffuse. If it's for here, it'll give me a result of 0, 0, -1. So it'll give me a negative blue channel, which is what I want, because that way it'll make the blacks go down and it'll make the whites rise. And then I can just take this and I can put it straight into B. So that way I have a symmetric displacement, meaning that I have the same amount of displacement into the material or into the object as I do coming out of the object. Obviously, you can change that around based on your preference and based on your use, and it should work. Oh yeah. So one thing I didn't do here that I forgot to do is I forgot to transform the vector. Since I'm using a tangent normal map or a tangent displacement, I'm going to need to transform it. So I'm going to need to change it from just the tangent to the world. So let me show you what's wrong with it. You can't really see it. So if I pump this up to something like 5, come on, you can see that everything, it's only going up. It's not pushing the bricks out. Like the top looks good, top's displaced, but everything else it's still flat, and the mesh is being displaced upwards. That's because it's not going based off the world, it's displacing based off the local. So you want to switch it so that it'll turn the tangent into a world. So just use vector transform. It's set to default what you want, tangent to world. So you bring that to displacement. And everything works out nicely. So it may seem strange to have both a bump offset and a DX11 displacement together, but what I found is when you use them both together, the bump offset allows you to really accentuate the displacement that's already there, because what will happen is if your mesh isn't really high poly, the tessellation, this is a tessellation, the tessellation itself doesn't give you a high enough vertice density to really get a good displacement out of it. So I wouldn't want to pump this up very high, because then it'd start to look really distorted. And as I move around, because as you can, if you check it, obviously the amount of tessellation changes as you get closer and further away. And so what that means is as I get closer and further away, the mesh will sometimes ripple. So what this allows me to do is you can use less of a displacement and still sort of supplement that with your bump offset, and you get a pretty good looking result. Alright, so that's how you make tessellation work, and that's how you use DX11 in this case. So now I'm going to set up a material constant, or I'm going to set it up for using a material constant. So everything I've got now is a standard, it's just one texture. I can't use it anywhere else. So what I want to do is, if I were going to use this for a constant, I'm not going to change this now, is I change all my texture samples. You just right click them, and you hit convert to parameter. So what that'll do is it'll allow you to just literally plug in a different texture later. But for these things, for the stuff I'm going to change now, you're going to want to multiply these, set up a multiply node, if it's taken forever. And then you're going to want to do parameters, and then scalar parameter. And then I'm going to name this dx height, and I'm going to set it to 1. So then literally you plug both things. You plug this there, and this becomes the new value for that, basically. What this means is you're just setting it up so that this can be multiplied by this, which dynamically changes it when used in the material constant. I'm only going to do this for now, and I'm going to show you the final result of the other one, just so you can get an idea for what what I actually did. Right, so now that that's all set up, basically, I'm ready to go modify this in a material constant. So it's going to save that. So I already have one set up. This is for the example material. It's got DX11, and because the default mesh isn't tessellated enough, it'll look really weird. And so I'm going to bring in the one that I made just now, and I'm going to put that into parent. So this is my material. You can see the rocks jutting out. And so parameter groups, for parameters, you got texture parameters, vector parameters, scalar parameters, and like you've got all these Boolean parameters and things. There's a lot of cool stuff to play around with, but for the sake of this tutorial, I'm just going to show you the scalar parameters. So right now I've got my dx height, and because I didn't set it 1 to 1 like I should have, because I was just showing stuff off, it's not going to be perfect, but you can sort of see as I decrease this, the amount of height there switches. It makes the rocks go in and out more and more and more. So if I applied the material constant to the rocks instead of the material, you get a better idea of what's going on. So what this means is literally as I'm going, I can just sort of swap this around, and I don't need to go back into the material. And because you saw how long it was taking earlier, and mess around with that, I can just go here and change some values, and it works out. I can make it negative if I wanted. I don't know why I'd want to. And so that's the basics of how that would work. Since it would take a while to go convert everything, I'm going to show you sort of the final result of what everything would look like once it's all parameterized with the example material. So basically what I've done here is it's slightly different, but it's mostly the same. So I have the texture coordinates, and I'm multiplying the texture coordinates by another parameter, and I'm calling that UV scale, which means that as I change that, it changes the amount of UVs. So if I open it up here, I got my parameters, scalar parameters. I've got dx height value, height ratio input, and UV scale. So you can see the two textures here. I can make this 2, and it's that much smaller, which is nice, especially when you're just adaptively, when you're building a level. The only problem is because it's tessellated, and because it's a tiling material, but because the material doesn't necessarily, it's not even, you got to make sure that they're even not even numbers, but they're whole numbers. Integer values won't work because of this nice looking seam right here. So basically that's how it looks for anything that's not a whole number. So as soon as you get closer to a whole number, it lines up. So just be careful of that. So you got that there. I've got my height ratio input, and so I have the texture set up so it's the same for every different texture. I literally just copied it, and since it's the same name, it'll modify the same variable. For height ratio input, I created another scalar variable, parameter, and called it height ratio input, and it plugs into this, which basically what it does is it's basically this number, but it's how much height is displaced and how much height you see. So if I go over here, so right now I have it set to something low, but so what it allows me to do is it allows me to essentially accentuate the punch of the DX11. So if I turn this down to 0, you still got some of that 3D, but if I turn this to 0, so right now all you've only got the normal map for depth. If I up this up to something like 1 or 5 or whatever, you can't see much. Then as I increase it, you can start to see a bit more, a bit more, a bit more. Actually, I'm gonna up this to 2 just so you can see the effects are a lot greater. But as I increase that, you can see a lot of these edges they're distorted and they're not nice and smooth. They're not what you'd want. Like if you had to walk through a cobblestone courtyard or something and everything looked like this, it wouldn't look good. So what you can do is you can drop this down to a level that does look a lot better. It looks a lot sort of more correct and everything. And then you can up the height ratio input. You can get a lot more bang for your buck. So that way it looks a lot more depth. Looks like there's a lot more depth and it's a lot more displaced, but you save out on a lot of that just error and artifacting using this. So you can combine them together and you can get something that looks pretty good. It's not too expensive and it's pretty easy to set up. So that should be it. If you have any questions, be sure to leave them in the comments and I'll answer them as quickly as I can and as well as I can. Tell me what you want to see next. And thank you very much. This has been Digital Seduction's tutorial on making pretty complex materials using one texture. I'll see you around. Bye.